Are you running?
Yep.
Okay. So it's so nice and smooth, just to show you that there is no, look, the tiniest amount of backlash. But can you see, get on my thumbnail, can you see my thumbnail moving the smallest amount?
Yep.
I reckon it's like probably a millimetre of backlash, not even that. Now I'm going to spin it. And look how that is absolutely smooth. No binding, nothing. Look at that. That's really nice. Look at that. No notchiness. It's just beautifully smooth, isn't it? Look at that.
Yep.
Yeah? Look at that. Can't say fairer than that. Now if I put the other half of the case on. Right, so put this half of the case on now. And we'll just pinch it nice and tight. Okay. Now, again, I'll just hold that with my little finger. I'll hold this with my little finger. Again, look, there's the backlash. You getting that? Getting that?
Yeah.
That's just a nice little tiny bit of backlash. Okay, and again. Yeah?
Yeah.
And obviously it's not, because it's running the second bearing, it's just creating a little bit of drag, you see, because it's just dragging that second bearing, that's all. It's lovely and smooth, no problem at all. Okay, so, but obviously, yeah, these bearings, because actually these bearings are still quite new, so the grease in them is creating a lot of drag. And if anything, that bearing has got more drag on it because it's in better condition than this bearing, which is probably taking more load. It's twisting the shaft under load, so I bet you this bearing's a little bit more worn, which is why it spins really freely. Yeah.
I notice you've put a spacer in, Ross.
Actually, I'm running a bit of pitch as well. That's why. But I accidentally knocked the pitch like that. That's why. Look, it slows it down. Look. Yeah. If I take the pitch off, then of course it's going to be better. So it'll probably be like that. That's why it needs to be like that. Now it'll run better. There we go. That's it. Yeah, now it's going to go forever, isn't it? Well, not forever, but you know. And yeah, there is a spacer. Okay, so if we take this apart, there is actually a spacer in there which I put in there, just there. You can just see in there, and that was to take up the spacer in here, which is it's just the end float inside the box. So there's just, when the box is together like that, there is the tiniest bit of end float in there. It's hardly anything. I mean, you hardly feel it. It's just enough that it's not binding. You can't see it. It's too small. But there's just, because that spacer, I could either put the spacer there or put it on the end there, and I thought, for convenience sake, that if you move that out and then put the spacer on this side, then you don't ever, if you take the gearbox apart, you're not going to lose that spacer and then forget and then put it back, and then this gear doesn't mesh with that gear, and then the next thing you know is it chews up. What is interesting, so it's always better on the Century box, they always put little spacers on the end there, but I actually ditched them and put them on the inside here, and that always seems to work better. Anyway, what is interesting is that you're absolutely right, the tooth profile here is, on here, the tooth profile is 45 degrees. Are you getting that? Can you see that? That tooth profile, if you come up over the top. Right, so I'm going to try and point to it with a little tiny pointer. That tooth profile there is 45 degrees. Okay, whereas the tooth profile on here is more like 30 degrees, actually. So, not 30 degrees, 35 degrees. So I reckon there's 10 degrees difference between this tooth profile and that one. So he's absolutely right. There is a mismatch on the tooth profile. However, they do mesh into each other so much. Look at that. So if that's first contact there, they actually mesh right into there. So, you know, and on inspection, when we look at all the faces of the teeth here are absolutely perfect. And when you look at the tooth contact points, there isn't even a witness mark as to where it's been. It's obviously made of a very hard material, and it hasn't even created a witness mark on the actual teeth, the teeth itself. So, yeah, I mean, you can see that on the video, but they are absolutely mint after God knows how many hours. So, leave well alone. Technically, yes, it's wrong. I think it is wrong. Tooth profile is wrong, but you know, swapping it out for a set of gears made by someone else, you know, if they're not hardened and they're technically correct, then they're going to wear away. So I'd rather go for these which we know work, because they do. So until something better comes along, you can verify the material. I mean, this stuff is hard as nails. You know, I'd put it back to how it was. It's absolutely perfect. And I would just do it on condition. So we just monitor it every so many hours, take it apart, have a look. If it looks as good as this, put it back. It can't go anywhere. Problems only start when you start getting strange wear and things like that. And nothing has happened here, so I'm happy. It's good. As a footnote, the only thing I would say as a footnote is that I mean, it's a pre-flight check you should always do anyway with any machine, but particularly this one, since if you're concerned about you know, tooth wear on the gearbox, since there are only 2 of these machines flying that we know about, and your one's fine, and obviously the other one had an issue due to tail gearbox problems, I would say check the end float. So the end float being one of the pre-flight checks is just when this is in the boom, get that and see if there's any end float. And if it starts to, I mean, there'll be a tiniest bit, but if it starts to get end float, don't fly, because it means this bearing's collapsing. And if this bearing collapses, then obviously the gear inside will become out of a line, and then that's when you're going to get problems. So I would say a pre-flight check is just wiggle that shaft, make sure it's solid and it feels good. You can't do it holding it like that, obviously, but make sure there's no nasty end float in it, and it's within parameters of what it should be. And then, and as long as that's okay, then you're good to go. So really, that bearing takes more load than this one because it's nearer the surface it's moving. This is obviously right. So this is the one that takes all the welly, and this is the one that's going to go first. So yeah, I would just keep an eye on that really.